Hey guys, this is your notes for 3.1. We're going to be working with quadratic functions today. So here are three different ways that you can write your quadratic functions. The first two we have already done in class, and you have seen. The last way, the vertex form, you have not, or you probably haven't seen before. But you will learn that today. Okay, so the first way is your standard form, which you have seen. It's the squared plus the x plus the c. Okay, so I'm just going to kind of break down the different types of things that you will find or that you can find from your standard form. Okay, first of all, remember a quadratic function looks like either a u or upside down u. Okay, and your parent function is y equals x squared. Axis of symmetry can be found by saying x equals taking your b and putting that over 2 times your a. Okay, remember your axis of symmetry is right down the middle. So I can find that, and it's going to be an x equals equation. Okay, your x-intercepts are always going to be an x comma 0. You can find that by setting your y equal to 0 and then factoring and then solving for x. Concavity just means which way it faces. Or actually, I'm going to say which way it opens. Does it open up or down? And what tells you this is your a value. If a is greater than 0, it's going to open up. If a is less than 0, then it's going to open down. Your vertex goes along with your axis of symmetry. After you find your x value, then you can plug it back in and get your y value. So your vertex should be an x comma y. All right, and then your y-intercept 0 comma c, and that c comes from right here. But factored form is what we normally, or what we have been doing. So in order to find some information from your factored form, I'm going to start with x-intercepts. So x-intercepts go kind of along with your standard form. So y equals to 0, which you've already done. Factor it, which in this case, it's already done. And then 3, solve. So in this case, what it's going to look like is when you say x minus r, then that's going to be your value. So x equals your number, whatever that's. It looks funny because I just have variables there. Concavity is still going to be the same thing as above. Okay, I'm going to back up to axis of symmetry. Okay, your axis of symmetry is still going to be an x equals, because remember we're going down the center here. We're going to take our r values here and say the average of them. So r1 plus r2 over 2. Since your axis of symmetry and your vertex goes together, okay, after finding your x, we need to solve for y. You should have an ordered pair, which is x comma y. Your vertex is this point right here, either the lowest or the highest point. The y-intercepts, in this case, because this is a 0 comma number, since this is not already solved for us, we're going to have to do a little work here. So in this case, I know that x equals 0. All our x's in as a 0 and solve for y. There is not a problem on the homework on this, so I'm going to give you an example that would be nice for you to work. You've been doing these, so it's not a big deal if you don't do this, but I'm going to give you an example. If you take f of x and do 3x squared plus 3x minus 36, I would suggest to go change to factored form. So in the end, it should look like this right here. So basically, you're just taking this function and factoring it, which is what you've been doing. On this last one, here's our new one. So I want to just go through how you find stuff first, and then I'll tell you how to go from like standard to vertex form. So if a is greater than 0, it opens up. If a is less than 0, it's down. Y-intercepts. Y-intercept, this has to be 0, comma, a number. Therefore, in your equation, you need to plug all x's as 0. Solve for y. Axis of symmetry. On this one, The whole thing about vertex is that it gives you the vertex of your parabola. Your vertex comes in, I guess I need to tell you this, your vertex is your HK. So if I know my vertex is HK, or basically this is your X, Y, then on your axis of symmetry here, all you can do is look at, if you have an axis of symmetry, and I know this is H, comma, K, then if I'm writing a equation that is x equals, then my x equals is going to be whatever my h is. So x equals whatever this is right here. So x equals whatever my h value is. Okay, on my x-intercepts, there's no trick here. Just like my y-intercepts, this is going to be a number, comma 0. So I'm going to have to plug in values again. Plug in y equals 0, and then you're going to have to solve. Solve for x. Unfortunately, this might mean you have to factor. Not always, but you might have to. I would pause the video and I would try to simplify this problem, the next problem on the other side. It says to convert from vertex to standard. Now remember, standard is just your ax squared plus bx plus c. Okay, remember when you have a quantity like x plus 2 and it is squared, that means you write it twice. When you multiply this, x squared plus 4x plus 4 minus 1, that will give you x squared plus 4x plus 3, and that is your new function. This is vertex form. This is standard form. Okay, in vertex form, remember this right here is your vertex. Just to kind of give you an idea, writing it out here. In vertex form, your vertex in this case, because this says x minus, in the parentheses, remember everything is always opposite. So my vertex is actually -2, comma, -1. Outside is always the same. So that's my vertex. Axis of symmetry is x equals -2. And I know that because I pulled it from my vertex. It says change from standard, which all of these are in standard, and now I want to go to vertex. This is called completing the square. You are going to take your first 2, and I'm going to write x squared plus 4x. And I'm going to leave a blank and close my parentheses because I'm trying to get this right here. I happen to not have an a value. It's actually 1. So I'm trying to come up with this right here, okay, my squared quantity. So I'm going to write x squared plus 4x. I'm going to leave this quantity right here, and I'm going to write 1 outside, and I'm going to bring my 3. Now, when completing the square, I'm actually going to add something to my equation, but I can't change it. I'm going to take my middle term, and I'm going to half it, box it, and square it. Whatever I get goes here. So 4 halved and squared gives you a 4. Now, earlier I said I have to add something to my problem that does not change it. But I just added 4, so I just changed my problem. So since I added 4, I have to subtract 4. So now, basically, I've added nothing to my problem. So if you add 4 and subtract 4, you now have not added anything to your problem. So now I can write my problem in vertex. This right here can be factored. X squared plus 4x plus 4, you can either factor it, or here is your, this is x plus 2 quantity squared. This 2 I got from the box. Then outside, I'm going to take this information right here, which is -1. So f of x, and this should be my answer. So I have a quantity squared, and then I have a number outside. Okay, so I'm going to walk that out again. You take your middle term, you half it, and square it, and that term goes here. Whatever you add, you must also subtract, because this has to be 0. This right here in this parentheses has to be the same as this quantity squared. So if I were to multiply this, it would give me x squared plus 4x plus 4. Okay, if you check your previous problem, these should be the same. If you notice, this has an a value. When you have an a value, it is a little bit different as you factor it out. The important thing is that I am going to factor it out of only the first two terms because that's all that goes in the parentheses. So I've added a blank here. I'm going to add a blank here, and I'm throwing out my 36 way out here. I didn't take a 3 out. I'm just throwing it out. Remember, this middle term, I'm going to take the whole thing, the -8. I'm going to half it. I box mine, and then I'm going to square it. That whole boxed thing goes here, the whole thing. So -8 divided by 2 and then squared goes here. So that is a +16. Normally, you would say a +16 goes here and a -16 goes here. Because remember, you always have to do the opposite. But I just threw a wrench in things and said, I pulled out a 3. Okay, so really, I didn't pull out a 16. What did I pull out? I really pulled out a +48 because 16 times 3. So I have to say -48. And now those are equivalent. So now I'm ready to write my answer. F of, you keep your 3, you can't throw it away. This parenthesis is the quantity squared. This is x. You can either factor this parentheses to tell me what it is, or you can say x and tell me what's inside the box. Inside the box is -4. Then outside is whatever you get here. -48 plus 36 is -12. I would suggest you try 3 on your own. So I would suggest you pause and then watch it. But I know you probably won't. So here I'm going to factor out a -2 only on the first two. So x squared, that's a 2, -2x, blank, plus 4. -2, halved, box, and squared. That goes here. Remember, your box goes here. So -2 halved is -1 squared. -2 halved and squared, that's still 1. Okay, but we have to think about what I really added here. So -2 times 1 is -2. So I have to add a +2. Ready to write our answer.